Okay, so with this one, obviously cos x can't change. It has to be cos x. You can't change that. Okay, so you're going to need to think of how I can change this one to cos squared. Because then I've got a cos square and another cos square and a cos. Then I can use like trinomials, factorizing trinomials if it's necessary. Okay? So it's not going to help you to make this one sine square cos square minus sine square because there's no sine x anywhere. There's just a cos x. So we want to change the cos 2x to 2 cos square x minus 1. Okay, so we're going to say 11 cos square x minus 4. And then we change the cos 2x to 2 cos square x minus 1 equal to 6 plus cos x. So you just change this one first and now you multiply in, so you're going to get 11 cos square x minus 8 cos square x, and then minus and minus gives you plus 4. You can take these ones over, minus 6 minus cos x equal to 0. So remember to when you factorize, you want, and when you have a trinomial or something, you want it to be equal to 0. Okay, so you want to take everything over to get it equal to 0. Okay, so now 11 minus 8 gives you 3 cos square x. And then there's a minus cos x. And then 4 minus 6 gives you negative 2. Okay, so that's where we are now. Now it's like you can say in standard. Okay, so let's say, just an example, let's say you had this 3x squared minus x minus 2. Let's say that was what you had. 3x squared minus x minus 2 equal to 0. And I said factorize it. What would you do? Obviously, you're going to use 3x and x. Okay, 3x times x is 3x squared. Now you want to get to negative x in the middle. And so if you want to get to negative x, here, 3x times negative 1 is negative 3x, and then plus 2 times x is plus 2x. So then negative 3x plus 2x gives you negative x. So we're going to have to make this one negative 1 and this one plus 2. Okay, so 2 times negative 1 is negative 2. 2x minus 3x gives you negative x in the middle. So this is what you would do if it was just normal x's. Okay? But now, instead of having x, you just have a cos x, cos square x, and cos x. Okay? So we use the same method. We just put in the cos x in the place of x. So it's going to be 3 cos x plus 2 and cos x minus 1. Okay, so we still factorize it like that. Okay, so we're going to have 3 cos x plus 2 and cos x minus 1 equal to 0. Okay, so we can take this part off. That was just to help you understand the factorizing. Okay, and now we can use the same method. Now you can just say cos x, therefore cos x is equal to negative 2 over 3. And here, or cos x equal to 1. And then from there you can solve it. You can now check cos x equal to 1, it's at 0 degrees. At x equal to 0 plus 360 times n and z, or x equal to 270 plus 360 times n and z. So this is where cos is 1 at 0, and then actually at 0, no, goes all the way around at 360. So now it's just this solution. Not at 270. At 270 it's going to be at 0 again. So it's just this one. That's the only place. If you think of a cos graph, it's like this. Okay, at 0, it's 1. Okay, cos x is 1 at 0. And then when you get to 360, it's 1 again. So there's only one place where cos is 1 at 0, and then after 360 again. Okay. So that's for the cos graph when it's 1. And then for this one, it's negative. Obviously in the second and third quadrant, cos is negative. So check what is second function cos 2 over 3. You can put that one in.
maybe.
48,19. Okay, and then obviously plus 360 times n, and then all the other one would be x equal to 180 plus 48,19 plus, and then you can just simplify that, the last part. Okay.